All right, so there's kind of like there's two actual states that the diode can be in, and can either be in a forward bias or a reverse bias. And then there's two failures that it can either be. Then it can either be shorted or an open. So sometimes it's kind of hard to tell the difference between a reverse biasing and an open, because when it's a reverse bias, it's already an open. When it's forward bias, it's going to look like it's being shorted. So if I had a diode here, yeah, plus and minus 0 volts here, and we'll say so what state is that diode going to be in?
Forward bias.
Forward bias. It's going to be in a forward bias because if we circle our active component, put in our polarities in there, my anode side is more positive than my cathode. My cathode side is going to be, relative to my anode side, it's going to be more negative. So my polarities are matching on each side of that. It's going to be forward biasing. And my diode, if I were to take a voltmeter across there and I measured it, I'd measure my 0.7 volts going across there. So it's a forward bias, it's turned on, and it's going to take its voltage first, and it's going to drop to 0.7 volts. So what state is it in this state? Oh, that should be that's a bad numbers here. Not that you would have caught on to it, but let's see here. That was bad. That was you would never well, I'll show you here. I'll put that back up here. Show you why. Let's just. These are bad numbers, so let's take a look at why this would have been bad numbers. So what state is that?
Reverse.
That's in reverse bias, and so if that's in a reverse bias, that diode's going to do what?
It's going to act like an open.
It's going to act like an open, and it's going to drop what for the voltage?
Source voltage.
Source voltage. So my source voltage is going to be, if I had a very simple circuit, what would be my source voltage then?
5 volts. Oh wait. 4.3. Ooh.
Yeah, so you can. So if I were to measure, so let's take a look, because we know these are bad numbers, so it's going to be confusing. So if I measure my voltage across this diode, my diode would be measuring what across for voltage. If I put a lead on each side of this diode, my voltage would be what? So just take the difference between these two numbers.
0.7.
0.7. So we know that my source voltage isn't 0.7 though, because we already have at least a plus 4 volts on this side and a plus 5 volts on this side. So that's how I realized that I threw in some bad numbers right off the bat there. So yeah, that wouldn't be a legitimate unless we had dual-ended power supplies, but we won't get into that. Let's see here. So So let's all right, there would be a good one. So now what would be my, what state would that diode be in?
Reverse bias.
Now it would be in the reverse bias. It's going to act like an open, and it's going to drop the source voltage. And what's my source voltage? All we're looking for is just the voltage drop across the diode. So what would be my voltage drop across the diode?
Negative 4.3.
Yeah, and it would just be 4.3 volts. It's not, no polarities because it's just a voltage drop. Remember, only test points have polarities. So yeah, so it would be a no-go, it would be in a reverse bias. It would act like an open, and then it would drop my source voltage. Now, what state would it be in?
That's an open. So
What would I measure for voltage going across my diode?
0 volts.
0 volts. If I measure 0 volts, I'm
Short.
short. Okay, so that would be a shorted diode. Let's see here. All right, what state would this one be in?
No go.
Yeah, it would be in a no-go state, right? It's kind of not really, it hasn't really reached that forward biasing part there, right? Because we need to have it, forward biasing, we need to have at least what for voltage?
0.7.
0.7 volts. So it's kind of into limbo. So it's still going to act like an open, and it's going to drop its 0.6 volts, but there isn't going to be any current going through there. It's not, or it's going to be a very small amount of current going through there. And it's going to be kind of right in that in-between state. And we'll take a look at that on our characteristics curves when we see that. But yeah, we need at least 0.7 volts to get that diode to turn on. All right. So those are kind of the 4 states that the diode can be in. All right, let's go back to our worksheets there. So did on worksheet number, or lecture number 2, we went over that one. How'd that one go? That one, did you want to duplicate any more of those, or did you want to move on to the next one? Move on? Yeah. All right. All right, so lecture number 3 is all right, so I have a negative 6 volts. What's my first step that I want to do when I'm analyzing the active component? Yeah, or the semiconductor or the active component. And then put your polarities inside there. And then what's my next step?
Treat the diode as an open.
Yeah, treat that diode as an open. So we're going to treat that diode as an open. And then we're going to kind of do it like if we're going to be doing test point measurements. We're going to measure what the voltage would be on the cathode side, and then we're going to measure what the voltage would be on the anode side. And then the word that I was trying to think on Monday, but my head was a little scrambled up, was what we call these we call them soft voltages. And so what we're going to do is we're going to bring down what we call our soft voltages. Meaning that when we treat that diode as an open, these are just to analyze the diode itself. So what would I measure for voltage on the cathode side? Yeah, a negative 6 volts. So again, negative 6 volts on this side. And then what would I measure for on the anode side?
0.
0. Yep, plus or minus 0. Should we have our polarities, because it's important when we're looking at solid state devices that we have our polarities in there. So these are so the ones in the red, those are just our soft voltages until we analyze the diode to find out what state that's in. So what state is that diode in?
Forward bias.
Forward bias.
Forward bias. Because I'm more negative on my cathode side than I am on my anode, and my anode is more positive than my cathode. Either way, whichever way you want to look at it. So then we know that it's in a forward bias, so we know that it's going to be a what? Go. And it's going to drop what for voltage?
0.7.
What was it?
0.7.
0.7 volts, yeah. So in the blue, those are going to be our hard voltages now. So we know that diode is, and so remember, just always keep, kind of the rule of thumb is that the solid state devices always are going to take their voltages first. So before you calculate out any other voltage drop, give the diode its voltage first. Whether it's either if it's reverse bias or the forward bias, always give the diode its voltage first. So then once you give the diode its voltage, then what's going to drop across R1 then?
Negative 5.3 volts.
5.3 volts.
5.3 volts. Yep. Just remember, voltage drops, no polarities. And then the other thing I want to do too, once we analyze that diode is a go or no go, once we determine that diode is a go, we know that there's going to be current going through it. So once we know what that current is going through that diode, another good step is always just to kind of put in the direction of the current flow through the diode. So which way is this current going through this diode? Is it going south to north or north to south?
North to south.
North to south. Yep, because it's more negative here, going to more positive. So it's going to be going down this way. So our polarities are going to be negative, positive across the diode, and that means that's going to be negative, positive going across our R1. So then our current is going to be going just like that. All right, then once we know the voltage of the diode and the voltage of the resistor, then what's my voltage of the test point going to be? I think I heard somebody say it. Negative what?
5.3.
Yeah, 5.3 volts. It's the test point, so this time we're going to have our polarities on there. So it's going to be a negative 5.3 volts. And then what's the current of my diode?
The resistor value.
Yo, you guys don't have the resistor value on it?
Yeah, we most of it is.
Oh, 10 ohms. That's all the resistors are going to be 10 ohms. That's why, yeah, you're right. I have it on my sheet, but I don't have it on this sheet. So then what would be the current of the diode then?
1.887 amps.
1.88.
Wait a minute, I think I did my numbers backwards.
Yeah.
Sorry. 530 milliamps.
There we go. 530
Milli.
milliamps. So what's another name for R1? What's the purpose of this R1? Current limiting.
Limiter.
We always have to have that current limiter. If we're using any solid-state devices, we have to have a current limiter. Now, sometimes these current limiters are already built into our integrated circuits or our ICs and stuff, so we don't need them. But typically, like if we're using diodes, transistors, FETs, or anything like that, we're going to always need to have that resistor always has to be in there. Or LEDs, that resistor always has to be in there. Because no matter what, this diode is either going to want to drop 0.7 volts or the source voltage. And so if I have a power supply of 5 volts, and I just put it across that diode is still going to try dropping to 0.7 volts. So it's going to just act like a short across that power supply unless it has that current limiting resistor in there. Yeah, I mean, it always just wants to drop that 0.7. That's all it wants to drop. So otherwise it acts like a short and it'll heat up pretty fast and ends up burning out. All right. All right, let's see my first step.
Circle your active component.
Circle the active component. And then put your polarities inside there. Okay, then what's my next step?
Treat it like an open.
Treat that diode as an open, and then we're going to bring, what did I call those? Soft voltages. Good. So we're going to bring down my soft voltages as I treat that diode as an open. So from referencing it to ground to the anode side, what would I measure for voltage using my polarities? Yeah, negative 6 volts. Okay, and then on the cathode side,
Plus or minus 0.
plus or minus 0. All right, then what's my next step?
Check and see what's forward bias, reverse bias.
Right, yep, check and see. So is it forward bias or reverse bias?
Reverse.
Reverse, yeah, because I'm more negative on my anode side and I'm more positive on my cathode side. So my polarities aren't matching up with what my active component is, so I know that it's a reverse bias. And then diode's going to act like a what? Open, and it's going to do what?
Measure source voltage.
Drop the source voltage. So it's going to be considered a no-go. And it's going to drop the source voltages. And my source voltage is what?
6 volts.
6 volts. Okay. And the current going through my diode is going which way? North to south or south to north?
Not.
It's not. There is no current going through there. Right. Yep, because it's an open, so there's no current flowing through there. All right, so then my voltage at my voltage across my R2 is going to be what?
0.
0. And then my voltage at my test point is going to be what?
0.
0.
Plus or minus 0.
Yeah, thank you. Plus or minus 0 volts. And then my current going through my diode?
0.
0. We already determined that. All right. Alright, negative 6 volts. 10 ohms across the resistor. Okay, my first step. Circle the active component. Put the polarities in there. Then my next step then is what?
Treat it like an open.
Treat it as an open. So on my cathode, I'm going to measure what for voltage?
6 volts.
Negative 6 volts. And then on my anode side,
Plus or minus.
plus or minus 0
0.
volts. Okay, is the diode a go or a no go?
Go.
That's a go. And it's going to drop what for voltage?
0.7 volts.
0.7 volts. The current going through my diode then is going north to south or south to north?
North to south.
North to south. So always just put in your current flow going through your diode, and you know that your polarity across there has to be negative positive, and that means that's the same current going through the direction of the current is going through the resistor. What's my voltage across R3 then?
6 volts.
5.3.
Yeah, 5.3 volts. Major amount of the voltage. So then my voltage at my test point is going to be what?
0.7. Isn't it?
Negative what? Negative 5.3. Negative 5.3. Everyone agree with that?
Wouldn't it be 0.7?
Yeah, be 0.7, right? Because we're measuring across the diode, so that would be a negative 0.7 volts. So remember, just go back from the old DC days, way back to chapter 4, 12 chapters ago. Take your red lead, bring your red lead down to your black lead. First sign you see is going to be negative. Look at your voltage drop, so you got a negative 0.7 volts and then back up to ground. So yeah, it should be a negative 0.7 volts. Then in the current going through the diode,
530 milliamps.
530 milliamps. This is a fun bit getting back into the DC stuff. You don't have to remember all the different units, voltage peaks, peak to peaks, RMS. You just stick with the old unit now.
Thanks for the reminder, Bokai. Bokai's ringing back here.
Saturday. All right, that's one here. What's the guy doing back there?
Shutting his ringer off.
Huh?
Shutting his ringer off.
Doing what?
Shutting his ringer off.
Oh,
sorry.
Volkai, what ring?
He changed it.
You don't know?
He just kind of breaking out into some little hip hop back there or something like that. Okay. All right. What's my first step?
Circle active.
Circle that. Go on. You're gonna get tired of me hearing say that all the time. Okay.
Treat it as an open.
Treat it as an open. I'm going to bring down my soft voltages. What do I measure for my soft voltage on my anode side?
Negative 6 volts.
Negative 6 volts. Now we're into our polarities. And then on my cathode side,
Plus or minus 0.
plus or minus 0. Go or no go?
No go.
No go. So the more negative on my anode side, the more positive on my cathode side. So my polarities aren't matching up. So it's going to be a no go. And the diode's going to drop its voltage first. So how much voltage is going to be dropped across the diode?
6 volts.
6 volts. Source voltage. Okay. Then the voltage going across my R4 then?
0.
0. My voltage at my test point?
0. It'd be 0.
Yeah. So I should, these aren't soft, the reds are soft voltages. The blues are the hard voltages now. There you go. So what's my polarity across my diode, right? So bring my red lead down to my black lead. What's the first sign I see?
0.
Negative. But my voltage drop is 6 volts, so I'm going to get a negative 6 volts. All right. What's that? Oh, okay.
Surprise, surprise.
Yeah. Alright. Alright, any questions on that one then? Pretty straightforward then? Alright. They give you resistor values on this one?
Nope, no. Just in the
That's You better go to the bathroom. Yeah, that Monday. There you go. So basically all resistors are 10 ohms. All right. So what's my first step on this one?
Circle your with your polarities and circle.
Yeah. So circle the active component. Put the polarities inside there. Then what's my next step? Yeah, treat that diode as an open. Then I'm going to bring down my soft voltages to each side of it. Putting my black lead on the reference, my red lead up here. What would I measure for voltage on my anode side?
10 volts.
Plus 10 volts.
Plus 10 volts. And then what would I measure for voltage on the bottom side?
Plus or minus 0.
Yeah, plus or minus 0. So those are all my soft voltages. Okay, that diode go or no go?
Go.
No.
That's a go. Go, and then it's going to take its voltage first. And what's the voltage across the diode going to be then? 0.7 volts. Okay. Then my direction of since we know it's a go then, that means that we know that we definitely have to have current going through the diode. Because remember, solid state devices, that they're current driven devices, so if they're being active, we know that they have to have current going through them. So my current going through my diode is going north to south or south to north?
South to north.
South to north. And that means that polarity across the other two resistors have to be in the same direction. Yep. Then I'll let you guys use your compasses on during the test and the quizzes too. All right. Then what's my next? What's going to be my next step then?
Figuring out the current.
Do we have enough information to find the current yet?
Figure out RT. Yeah, you can figure out RT.
Yes, we can figure out RT, but I don't need to really do that at this point. We can, but we need to find the voltages going across R1 and R2, right?
Oh, yeah.
So what is the voltage going to be going across R1 and R2? If they're both equal in resistance,
It's going to be half of 9.3 volts.
it's going to be half of the 9.3 volts. Because we know that the diode is going to drop 0.7. We know that R1 and R2 are going to have to drop the same amount of voltage. Then it's going to be half of the remaining amount of that 10 volts after we give the diode its voltage first. So it's going to be half of the 9.3 volts. So what's half of the 9.3 volts then?
4.65.
10 ohms. Okay. Now what's my next step? Yeah, we can do our test points now. We have enough information for our test points. We got all our polarities. We have all our voltage drops. So what am I going to get for test point A?
5.35 volts. Plus 5.3.
Yeah, positive 5.35 volts. And then at test point B,
Positive 4.65 volts.
that'll be a positive 4.65 volts. All right. Yep, so give the diode its voltage first. If we had two different values of resistors, then we'd have to use the voltage divider formula. Otherwise, since they are both equal in resistance and value, we just had to divide up the remainder amount of voltage across the two. All right, what's my first step? Circle that component, put the polarities in there. Treat that diode as an open. And then we want to bring down our soft voltages. So what's my soft voltage going to be on my cathode side?
Negative 10.
Negative 10 volts. And then on my anode side?
Plus or minus 0.
Plus or minus 0. Is that diode a go or no go? What is it? It's a go. It's a go. It's going to drop to 0.7 volts. My cathode is more negative, and my anode is more positive. So the current going through my diode is which way? North to south or south to north?
North to south.
North to south. Okay, then what's my next step?
Voltage
Prime
across the
voltage.
resistors.
Voltage across the resistors. And what's my voltage across the resistors going to be?
4.65 volts.
Yeah, same thing. 4.65 volts. Okay, my voltage at test point A is going to be what?
5.35. negative 5.35.
Right, this time it's going to be a negative 5.35 volts. And then test point B,
Negative 4.65.
negative 4.65. And always just, if you wanted to double check your work to make sure that you did it right, just if you went from test point A to test point B, what would I measure for voltage?
Negative 0.7.
Negative 0.7. So it always should equal up to the, so if you're double checking your test point voltages that you did it right, you can always just re-verify that you got that 0.7 difference between the two. All right.
Wouldn't 4.65 be positive or no?
Well, yeah, we didn't throw in our, because we know that the current was going north and south, right? And we forgot to throw in the polarities across our resistors. So we know that polarities across the resistors are the same. So I think so now if we bring our red lead down to our black lead, our first sign is going to be a negative 0.7 plus a negative 4.65. So yeah, it should be a negative 5.35. Yeah. Yeah, don't forget to throw in your polarities into your resistors, especially on the diode challenge. That one's it's a little tricky. All right. Circuit number 3. What's our first step?
Circle the active component.
Circle the active component. Put our polarities in there. Then my next step. Act as an open. Then my next step.
Should have on the cathode and the anode side.
Yep, so calculate what the soft voltages are. So on this side here,
Positive 10.
positive 10. And then on the anode side,
Plus or minus 0.
plus or minus 0. I heard already somebody say that it's already
No-go.
as an open. So it's going to be a no-go because we're more positive on the anode side. So it's going to be a no-go, and it's going to drop what for voltage?
10. Positive 10.
Yep, just 10 volts since the voltage drop. Just the voltage drop across the diode. It's going to be 10 volts. So the current going through the diode, which direction is the current going through the diode? North to south or south to north?
North to south.
It's not.
It's not. Yep, there is no current flowing through there. Yep. But current of the polarities across the diode are negative positive, so if you wanted to throw that in there, you can because it does help. So the voltages across the resistors are going to be what? How much voltage will be dropping across R1 and R2? 0. The diode is taking all the voltage. Okay, so then what am I going to measure for test point A?
10 volts.
Plus 10 volts, because I'm measuring across the open. And what am I going to measure at test point B?
Plus or minus 0 volts.
Plus or minus 0 volts. Okay? Alright, let's take and these next two are, I'll even give you a little heads up. These ones are a little tricky. And this is where we're going to start, when we're working with solid-state devices, it's going to be very critical, and I kind of mentioned it in DC a few times and stuff. But when we're working with solid-state devices, it's very easily to turn on another device by using our voltmeter. So when we're analyzing these next two circuits, we're going to assume that voltmeter is going to become part of the circuit. So let's, we'll kind of walk you through this first one here. I'll show you what I'm talking about here. All right, so our first one here is going to be our plus 10 volts. So we still analyze it the same way. We're going to circle our active components. We got two of them on here this time. So when you're analyzing a circuit that has more than one diode, which is very common because we can actually use these as logic circuits, so we can have more than one solid-state device in one circuit. It doesn't matter which one you analyze first, but you're always going to pick just pick one and treat that one as an open. So, for example, let's just pick the most logical one. We'll pick D1. So we're going to pick D1. We're going to treat it as an open. Bring down our soft voltages. So, what would I measure for voltage above on my anode side of D1? Plus 10 volts, because I'm still measuring across an open, so it's still going to be plus 10 volts. And then on the cathode side, I'm going to measure what for voltage? 0 volts, plus or minus 0 volts. So is that diode a go or no go?
Go.
That one's the go. And it's still going to drop its voltage first. And what is it going to drop for a voltage?
0.7 volts.
0.7 volts. Okay? So now that diode we're going to consider that diode a go. We're going to keep that in the circuit now. And so we know that that's going to drop to 0.7 volts. Now we're going to analyze circuit number, diode number 2. We're going to treat that one as an open, and we're going to bring down the soft voltage across that one. Assuming this one's turned on, that one's all working good, what would you measure for soft voltage on this one?
Positive. 9.3 positive.
Okay, so remember the diode is still an open, right? So it's still going to be 10 volts. Yep, still going to be plus 10 volts because I'm still measuring across an open. I kind of misled you when I said that. So we're just assuming that the current is going through there. But the voltage, so we're just assuming that it's going to turn on, but this is going to be measured across the open. So we're just going to assume that it's going to drop the source voltage. Yeah. I know. I don't have room to write all that. It's too messy sometimes. All right, so then on my cathode side, what am I going to measure for voltage?
Plus or minus 0.
Plus or minus 0. So is that diode a go or no go?
Go.
That's a go. And it's going to drop its voltage first, and it's going to drop what for voltage? 0.7 volts. Okay, so now each one of those are dropping their 0.7 volts. Now what can actually happen is that what's going to happen when I first apply power to these diodes, those diodes are going to do just the way we're analyzing these circuits, they're going to act like an open. So if we were able to measure that real quick, if I put an oscilloscope on there or something like that, and the minute I applied that voltage to it, I wouldn't get the 0.7 volts right away. It's going to treat like it as an open, and it's going to get my source voltage, and then that diode's going to turn on nanoseconds later, and then drop to 0.7. So we're analyzing it the same way that these diodes are actually working. So what can happen is that depending on how fast each one of these diodes react with one another, or which one is the quicker one to turn on. One can turn on another diode, and then shut the other diode off. So what you have to do then is you always have to kind of go back up through there and take a look and see if everything would still be a go. So you got to go back and analyze diode 1. So we'll keep that as our green here. So we know that diode 2 here is going to drop its 0.7 volts. The current is going negative, positive. So we know that our current is flowing this way. So when I'm looking at this, if I'm treating, let's do this. Let's calculate out what our test point voltages would be, because that's kind of doing the same thing what we're doing. So what would be my test point voltage at test point A?
8.6 volts.
What is it?
8.
Plus 0.86 volts. It's 1.11.
Yeah. So each diode is going to drop 0.7 volts, right? So if I'm measuring across the two diodes on test point A, I'm going to measure a positive 1.4 volts. On test point B, oh, keep that blue because that's a hard one. At test point B, what am I going to measure for voltage? Plus 0.7 volts. So if I go back and take a look and verify that D1 is still on, I got a positive 1.4 volts on this side and a positive 0.7 volts on this side. Would that diode be still forward biasing? Yes, because I'm more positive on my anode side than I am on my cathode side, and I'm more positive by 0.7 volts. And by measuring my test point A to B, I know that I'm still dropping 0.7 volts there, so I know that diode's a go, and I'm still going to get positive 0.7 on my anode side on the diode 2, and plus or minus 0 on the cathode side, and so I know that one's still a forward biasing. So those bolts still stayed on. Okay?
Voltage on the resistor is 8.6 volts.
Yeah. And the voltage on the resistor is going to be, now once they're about 8.6.
So if we actually have